Hey everybody, this is Mr. Munson, and let's go through some vocabulary that you're going to need to know for the 1.8 polygon video. So first up, polygon. So a polygon is a geometric shape that has three or more sides, okay? And we can talk about interior points and exterior points. So if you look in the figure here, under the example, you have three figures that are in green. And the interior points are marked in red and the exterior points are marked in blue. Okay, remember a point is just a location. Okay, so make sure you understand that before we move on. So now in the world of polygons, we have two types of polygons. One's convex and one's concave. So let me explain what convex is. Convex is a shape such that if I grab any 2 points, any vertices of the convex polygon and connect them, that new segment, that blue one, is going to be inside the figure. Now that might make sense to you anyway, but when I do convex, hopefully that'll pan out and you'll understand why that's so important. Hey, listen, I'm doing this in color and you can hopefully see those colors. If you do these all in pencil, it won't make any sense that I had a pentagon there first and drew a blue line. So you might choose like pen and different color pens, different colored pencils, or a pencil and pen to kind of make these shapes make sense to you later on. So here's a concave polygon. Basically, a concave polygon means two of the sides have kind of like collapsed in on the figure. And the way to tell if it's concaved or not is you can just put 2 points anywhere you want, and they should be either segments outside or inside. If I connect these two, these are going to be on the inside. That's not what makes it a concave figure. That sounds more like a convex, like I just did. But if I grab and put it there, then indeed I end up with showing a segment outside the figure. That's what makes it a concave shape. That's how you can test for you, if you will. Hey, remember that you should be writing your words on the other side of these papers and then cutting them and use them as a tool to study. In this figure, I kind of show you what interior angles are. I've listed the interior angles. 6 is not listed there because again, it's got an exterior, kind of an exterior idea to it. So 1, 2, 3, 4, and 5 are all interior angles. Okay, next up is exterior angles. And so in this case, I have these angles that I form by extending one of the sides. And so the exterior angles are always made up of one of the sides of the polygon and an extended side, okay? So if you look at angle 6, you have this extended side, and then you have this side, the other side of 6, which is here in black, forming that angle 6, okay? So 7 is formed by this extended side and this side of the polygon, okay? All right, very good. So we have those exterior angles. All right, and let me add a number of 10 there. If I have a 5-sided figure, I'm going to have 5 exterior angles. I left one off, okay? So all those that I have there marked are exterior angles. Take a look at something. Over here to the far right, I have that similar figure. I have that pentagon there. I extended one of the sides, 7, and it's made up of a side of the shape and an extended side, okay? That gives you angle 7. I'm sorry, I erased part of my drawing. I had to redraw it. Same shape. What I wanted to get to is this. As we get into this, you might realize that as I extend these sides and create these exterior angles, in this case I started on 7 and I end on 11. Down here at angle 7, I could extend this side and get this angle here, okay, which is an extension of that side plus the side of the shape. Now, the reason I didn't do that is I could do that at any one of the vertices. I end up doubling up the angles. What I know is that this angle right here that's written in red is identical to angle 7. I'm going to pause just for a second and see if you can figure out in your head why I know that 7 and that other angle are the same. So if you thought about it and you came up with a word that starts with a V, you're heading in the right direction. Yep, 7 and that red dot angle are vertical angles. So I really don't need to talk about and bring into this figure, this other figure. It's just a doubled up angle, right? So it's the same thing. But in any case, every shape has as many exterior angles as it does sides. This is a good example. Okay, I'm going to have you just put me on pause and run through these these blanks here, and write in the names of the shapes that you already know, hopefully, that have this number sides. Now, do as many as you can. You might not remember some of them. I've written in some of the more obscure ones, like 7 side is a heptagon, 9 is a nonagon. Um, 10 is a dodecagon or is a decagon, and 12, my absolute favorite, is called a dodecagon. I think it's just a cool word. Put me on pause and do the rest. All right, there you have it. Get those into your vocabulary words. Let's move on. Now, this last one says a shape with n sides. N is an unknown, or it just is a placeholder for something as we go through it. You know, so many sides, I don't know how many sides, whatever. So n represents however many sides is an unknown. So it's called an n-gon. I might be saying to you, hey, I'm thinking of a shape. I have no idea. It's an n-gon. And so you automatically know that it's a polygon, and it's got n number of sides. Okay, so for instance, a 20, sometimes we don't have special names for stuff as well. So like here's an example of 28, a 28 sided figure is called a 28 gon. So we can use it in that sense of naming figures, or I could just in general say, I don't know how many sides it is, I'm just thinking of an n-gon. All right, going on to the next page, and again, as I was just talking about n-gon and some other things, hopefully as we go through the video for 1.8, when you get there, some of this stuff will make a little bit more sense, okay? So here we have a regular polygon. A regular polygon is any sided shape. This example here is a 5-sided shape. Any sided shape that has the same angles measurements all the way around. So in this case, I have one marked in red saying 30. They're all congruent because I got that red congruent mark. And so they're all 30-degree angles. And then all the sides are marked as being congruent. One of them's 10 centimeters. So they're all 10 centimeters. And that's what we call a regular polygon. It's basically a polygon where all the angles are equal to each other and all the sides are equal to each other. All right, so now we have the polygon interior angle sum theorem. Basically, when we're looking at a polygon, in this case, I just drew a 5-sided figure. It could be in 6 or whatever. If these 1, 2, 3, 4, and 5 represent the angle number. If I add up whatever angles those were, 30 at 50 or whatever, they're just different angle measurements. If I added all those up, I could calculate what the sum of all the interior angles are. Okay, so if I added all those up, that would represent the sum of the interior angles. So that's what this formula means. Okay, and I'm just going to put a little I down there. The sum of the interior angles is calculated by taking n minus 2 times 180. The n again represents the number of sides or the number of angles. They're both the same. So take a look at this figure for a triangle. Basically, measure of angle 1, 2, and 3 added up equals, that's the sum on the left side, right, is equal to 3 minus 2 times 180, which is equal to 1 times 180, right, 3 minus 2. And that equals 180 degrees. So that on that 3-sided triangle, what I know is the sum of the interior angles all add up to 180 degrees. There could be 30, a 60, and a 90 in there. Lots of different angles that could be inside of a triangle, but they all add up to 180 degrees. Now the polygon exterior angle sum theorem is much easier. It basically says this: always, no matter how many sides this thing has, it doesn't matter if it has 21 sides, the exterior angles are going to add up to 360 degrees every one of the times. The sum of the interior angles changes with the number of sides. That's the definition we just talked about. The interior angles add up to being different each time depending on the number of sides. However, for the exterior angles, they all add up to 360 degrees. Now this formula works for a regular polygon, so all the angles inside are the exact same. To calculate what each one of the angles would be, is you would find the sum. That's what that n minus 2 times 180 be, right? That represents the sum of all of them. and then you divide by how many angles those are, right? So if you had 360 degrees total, you plugged in a number, you got 360, you divide it by however many sides, and it evenly distributes the total sum of all the angles together, some being added, and divides it evenly among each one of the angles. And so they would end up being, so every angle inside this regular polygon would be exactly the same. We'll see an example of that in the video for 1.8. And lastly, to calculate the exterior angle of a regular polygon, we take the exterior angle. The single exterior angle is calculated by taking 360, which all polygons, the exterior angles always add up to 360. And if it's regular, that means all the exterior angles are exactly the same. Remember, that's what regular means. So I take 360 and divide it by the number of angles, and that evenly distributes it and tells me how much each angle is. And again, we'll look at that in the video. Make sure you understand that. Okay, and that's all the vocabulary I have for you. Off to 1.8. Have fun.